Hello, hello everyone. Good evening. Now, what's the plan for today? Well, honestly, I have no idea, but we'll figure it out. Hello, Joe and Mr. Curry. I hope you're doing well. So let's just look at those points over there. The goals for this, it's just to make the simplest possible Rook, and not in simple as in design. I want to get all the parts as best as they can be, but I want to make a simpler Rook, which means less parts. It might be more printed parts, but it's less parts to buy, so hopefully this should be a cheaper design. All in. So last time we looked at what I've done off camera, which is just set up the general shape of it all, and then I made all of these. Let's pause this. I added all of these holes for clamping the frame to the uprights. So instead of just having a friction fit frame to the rods, then now it's a clamped version. And I'm thinking maybe we'll work on the Z-axis today, just to not just focus on one area, because we did the front idlers, which are done on this. So on what I'm doing here is I'm using the Rook Mark II, or the Rook 2020 belt path, but I'm changing it slightly to add tensioning on the motors in the back instead of in the front. Hello, Gaussus. How are you? So what my plan for Z was to have a lead screw, which is represented by this rod. Just can't be bothered to put in threads. And it's on a normal motor setup, the coupler. So I guess the next thing would be to design a T-nut. And this is where I'm a little bit torn. Do I use a anti-backlash T-nut, or do I just use a normal T-nut? So we might have to just look at specs for both of them. Let's see if I can find an image over on my other screen here that has the dimensions. Now, I am leaning towards just putting in the simplest lead screw nuts and then making it so that I can quickly adapt it to another anti-backlash one if I need to. Ooh, excuse me. Now, this is a lead screw nut with anti-backlash on it. So do I just recreate this and use that in the CAD, or do I put in a normal one? I guess the first thing I would figure out is if the hole dimensions are the same on a normal T-nut. Let's see. It doesn't look like it. use the same website. Do they have? That's not a lot of. Oh, look at this! Look at this! So it seems like they are the same. At least for this manufacturer is the same. I'll make it so that I can quickly change it if I figure out that the one that I have won't fit. But the general design of the hole should be pretty much the same. Which is, it's basically just this in a hole with a little bit of adjustability. So have enough so that the thing can move about 1 millimeter in total, and that should be good. So let's put that over there as a reference. So let's just design the part first. That will be the best way to do it. Let's make a sketch, and on this one I'm just going to design it as a revolve. So instead of having multiple sketches and then stacking upwards, I'm going to just do this. Inside there's a little thing there. Sure. Now the total width is 22 millimeters. So let's add that in. So 22, this is half, so divided by 2. And then the actual cylinder here is 10.2. 10.2 and then divided by 2. So the reason why I'm doing divided by 2 every time I do these measurements is because if I need to change something and I'm looking at a spec sheet, I just grab the number. I don't have to do any math. I don't have to trust myself of doing any calculation at all. So I'm just passing that on to, I guess, me not screwing up. There's this bottom piece here. So that's 2 divided by 2. So now this part, see over here is it's 1.5. I don't have to divide that by 2. Ain't happen. And then this one I don't have to divide that by 2 either. That is 10. And then this guy right here is 3.5. So that's all just dimensions from this sketch right here. Now the final measurement is this one. Now that's just a 8 millimeter hole because I'm not adding the threads into the CAD. There's just no point, and it's 8 divided by 2, of course. And let's keep that going all the way down. Hey Joe, that's okay. Someone has to do your job. that should be enough to do the revolve. I'm just going to revolve it around that. And there we have it. Let's rename that to screw nuts. Let's rename the document to screw nut 2. And then let's add in the holes. They are all on the same reference, so there's 4 of them. And I'll just add in that. It's 3.5. And this guy is 16. Circular pattern with 4x. See, to limit the movement of those guys. There you go. Now I can just extrude that sketch because there's only 4 things on it, and that is our lead screw nut. Let's change the appearance into kind of a brass-ish color. There you go. 1 brass lead screw nut. Now let's figure out where to put this thing. And I want it on the bottom of this thing right here. Now this thing is mostly done. The position of the bed is not final, but that won't change the back part here. So let's edit this in context. Editing in context means that I get the reference of the rest of the assembly. So for me to find the right spot for a hole, it's just adding it to there. Now you'll see the can adjust the position of the bed still. But this will be a new sketch. Let's get these out of the way. And what I'll do is, the first thing I'll do is add in that. Now I know exactly where that hole is going to be. I don't have to do any math. I don't have to measure anything. I know where it is. And I know that because I have the lead screw nut dimensions here, I know the external dimension here is 22. So let's put in 23. And we can see that it's slightly bigger than the thing is wide, which I can fix because I want this to be fully embedded. So I'll go up here, and this one is set to 22. Let's set that to 25. It does add bulk, yes, but it also makes it so that we can fully embed this nut into it. It should have a cleaner look. Then let's extrude that. So I'm going to do it so that the entire nut is completely embedded into this. So that means this 3.5 plus this 1.5, so that's 5. So I'll do remove and then 5 and then done. Now that gives me a location to put the lead screw nut, and then I need to get the actual hole in between all the way through, and that's 10.2, but I want some wiggle room. I'll make it 11.2. Remove. I'll do up to face, just so that if I change the size of this thing, it'll always go all the way through. Now let's do another sketch for the holes. And let's see. This will be a reference. And I'm just going to recreate what I did on the lead screw nut. Have a nice night, Mr. Curry. Hopo Banana, hello. So, what I'm working on is basically my own interpretation of the Rook. A full rebuild from scratch, adding some of the features that I want, simplifying it. Hello, P3D. Oh, this is 4.6 for threaded inserts. This is probably my only annoyance with designing for this, because if I now do, let's add in this one and then look at this dimension. That's 0.1, which means it won't print that hole properly. But I don't have a choice here. This needs to be in this spot. But I'm not using threaded inserts. I just realized. So I can make this back to 3.5. I should probably make it slightly bigger than that, but it's okay. And then I'll put in the nut size here. Make these two equal. And then I'll add in my variable, which is M3 nut width plus tolerance 0.2. This might be an issue. 0.35 difference. So I just need the lead screw nut to be far enough away that it won't hit that, which I could do. I can definitely do. Now let's make a circular pattern out of these two. Let's make it 4. So I can probably just put the lead screw nuts on the top. that'll make it super easy. You don't have to press fit them into like a little slot or anything. So let's extrude just these holes first. And then let's do this. So to face, but remove. And then let's do an offset. So that's 5, 10, so 12. That looks pretty good. Now, 3mm, and my nut size is 1.7. So that's pretty perfect. Okay, let's fix one thing that annoys me. Should just clean up that hole. Alright. Let's go to the assembly and look at that. Then let's add in these screw nuts. There we go. And those nuts will clear the brass nuts. So that fixes it all. Now, just to remind everyone that I'm still working on the whole big picture thing, getting everything in the right position. So nothing is finalized. I'm still at the point where if I need to change the size of this, I can. Because I can just go in here and check, oh, I need my frame to be, let's see, if I need to add in 5mm to my frame, that's my complete frame outside, then I can add in 10mm, that's 5 for each side. And then it'll update. So if I now want to make it slimmer on the inside, I can have that be 190. So what I've just done is I've increased the size of everything by 10mm. So nothing is completely set dimension wise. I can easily just change things quickly, which is how I like to work. I try to do it as much as I can. So the actual position of the bed is still not set. I showed you earlier that I can just go into the frame, the bed frame, and I can change that. You'll see that this sketch is not fully defined, which it's correct right now. So I have I have these two holes, which are the mounting holes for the V0 bed, and I can change this quite easily. So when I get to the gantry tool part, all that stuff, I can fine-tune the position of everything. Alright, that is the bed taken care of so far, at least. Let's have a sip of liquid. So let's keep going with the theme, getting all the big picture stuff in. How about we do feet? Such a simple thing. Now, I want to do some feet that makes it wider at the bottom. Not because it looks any different, it's just it adds stability. So let's design a foot. Should be in the frame. PART Studio. Now these should be pretty simple, I guess. At least I can't see a reason why they should be more difficult to make. Now, if I make it as simple as I can, I'll just make half of it and then I'll mirror that part. Let's add in the hole. This one I know. Let's just get this rough shape extruded and put into the actual CAD and see how it looks. I just need to double check. Did I do... Is this a variable? Let's go check the frame. Top frame. That is a fillet. And it's done by frame fillet, which makes this way easier. I'll add in that, just type in frame fillet. And this doesn't need to extrude that much, it just needs to extrude like points. Let's do one. Hello, Benjamin. So I'm currently just doing most of the big picture stuff, getting all the parts roughly in place where they need to go. Thanks for the sub, Benjamin. Now I just want to get everything looking like a complete printer, and then I'll fine-tune all the parameters of where everything is. But I'm doing all the little parts. So right now I'm doing the feet, then I'll do the motor mounts, then I'll start looking at the XY gantry But the way I design things is that if I need to move something, I can easily just move it. So let's have a look at this frame here. Let's rename this. So let's insert that foot. And I can just use that. No. There you go. So this now lets me find a position to put in a way to attach all of this. And I'll probably just make sure that I'm fully clear of this and then add in some M5 nuts to this. This is probably the one spot where I don't need to add a nut to this. Screwing it into the plastic would be perfectly fine, but I did promise myself that all connections should be into a metal nut, so that's what I'm doing. Now, how do I want this to look? I want the nut to have like a flaring effect of the printer. So, and then I want to know, let's add in a variable for this. Let's see, foot height. And then let's just make that 50. It's probably not going to be that much, but doing it this way makes it so that I can easily just change the height of the feet by changing one simple parameter. And looking at that, I already know that it's way too much. Let's do like 35. I mean, the only thing I need to consider here is room for the electronics, but and the Z motor, of course. I can also probably make a separate CAD model for the Z motor, just because I don't need that one to be as tall as the XY motors that I put in. So let's make this 50. And I'm going to put this in. Hello, Daniel. That's funny. I'm not gonna lie. Maybe I should just give this printer a completely new name instead of Rook mod. Alright, let's have a look at that. Size-wise, that seems correct. I know that a 2020 frame is better, yes, but is the difference enough to discourage one from making a peeler frame? No, it's not. So we already have the Rook. It's been working for a couple of years at this point, and it's a really good little printer to get you into 3D printing. It doesn't really lower the cost, but it lowers the point of commitment. You don't have to get a custom 2020 frame with extrusions or anything. because the cost of the PLA is pretty much the same as a frame these days. But it does simplify everything, and it also makes it more fun, especially for younger people and kids. Great little printer. It probably outperforms just about any one of the small printer you can buy off the shelf, not a kit printer. So PLA frames are really stiff. They're not as stiff as a metal extrusion based frame, but they are really, really stiff. I wouldn't go as far as using anything else for the frame though. I wouldn't do like a carbon fiber PLA frame. It just doesn't make sense because that is way more expensive than a 2020 frame. Alright, we have this plane here. Let's get those out of the way. Now, what I want to do is, I want to make it so that if I change this top part, the lower part will just increase in size too. So, I'll copy this entire thing and then add on here. And this will probably, this should just be a variable too, so I can quickly just change it. Let's do this. Foot flare. I have no idea if that's the right word, but I want a 3D printer so I can make another printer so on until I have 50 of them in my garage. Well, I have 10 at this point in that way, so it's not an uncommon way to get more printers. No. Is it the cheapest way? No. It's not cheapest in the slightest bit. I just realized that I've done something wrong. I should, actually I can delete that fillet right there. I'm going back into my first sketch and I will fillet. Of course I can't fillet that. But I can fillet that. These two, where are you? That one. I want those two to intersect. There we go. And I should probably just I'll have to redo this entire thing, but that's okay. Actually, no, I don't. That's pretty much what I need. Does not have a rounded corner right there. There we go. Now, sketch. let's go like that. Let's do what I should have done in the first place. I mean, I know of people that have a lot of printed printers. Not fully printed, mostly extrusion based, but I know people that have 30, 40 just project printers that they've designed themselves. I think I'll have to do this, that, then. Because I need something to fill it. There we go. Now let's just do a loft. Use those two. Oh, of course. I have to add in that hole at the very end, I guess. Which is not a big deal. Got an old Ender V2 clone. The Aquila, yeah, I know about that. I have heavy modified with Clipper and all that stuff. Nice. Yeah, resin, I've never gotten into it. I don't really have a use for it, but I mean, building your own printer, if you're already fully modified the Aquila with Clipper and all that stuff, you can easily build your own printer. Easily. So what I want them here is to do an add instead. So let's do put height, but then minus 4. Because I want to make this one 2. And then at the bottom here, I want to go out another 2. Just to nicely round off that. Yeah, resin prints, extremely nice looking prints. I'll happily agree with that. I mean, there are tough resins now that makes me want to maybe consider it, but for my use, FDM is still just everything that I need. I'm never gonna say never when it comes to resin though. probably a really good option for some things. So I want to look at this thing. So this right here, I should just do this actually. It would simplify everything. So let's path in these here. It's doing that little guy there. So I want to get rid of this whole thing, which means I'll just do that. Then that. Yeah. I want to make sure these are always parallel like that. Now I have to use a mesh connection. There we go. So that is the current look of the foot. So let's have a look at that in the frame. Let's do the full assembly. Here we go. Now we should probably just add in all 4 of them just to see how that looks. So let's go into the frame and add in 3 more. There we go. Then fastened that to that. I did see it, I'll fix it. Let's see. So what's this? All right. That is looking pretty good. Now, do I embed the nuts? And so I have one caveat here, and that is the fact that these square nuts, they're sold in packets of X amounts, and I need to keep that in mind for the total thing here. I don't want to use it like 1 packet and then 2. I'll rather have to reduce them. But I'll add in the slots for the nuts anyways. But first let's add the holes for that, which is pretty simple. Now oh yeah, this needs to get fixed. And I can do that here. Context, and now I can just match that one to that one. There we go. Well, these should be easy to print too, so. let's add in, let's go before the mirror, add in a hole. Oops, line. And on there, add in 2 circles. One is for the actual screw to go through, and the other one's for the head on the inside here. Or do we put the nuts in here and then the screw goes through the frame? Do I hide the screws, or do I have them visible? I mean, if I make them visible, I can use them. If I have them going from the top frame into the foot, that means I can use them to hold in the bottom panel, which is something that I want. So yeah, I'll make it. I'm gonna make room for a square nut here instead. Make that equal so that I only have to apply this once, and then M5 nuts wide plus tolerance 0.2. Now where to put this? And then I'll make it easy. Nice and easy. I'll grab this guy, remove through all, but then I'll do a starting offset of 5. That direction. Thank you. Then to make it easier to insert, chamfer, no. For all of these. To distance. That is strange. I want to add in a little bit of a relief for this hole so that inserting the nut is easier. So what I'm going to do is I'm just going to offset this entire thing by like 2 millimeters. That. That'll make it so you don't want to struggle to get that T-nut in. Then I'll just make it even easier by doing that. There we go. And when I do my final walkthrough, I'll add chamfers and fillets and all that stuff to make it print better and look better. There you go. Now here, I want to add a spot to put in a little printed TPU foot. We can do that by adding a hole. Let's see. Let's use this guy for reference. So if I want to just completely fill in that thing, that's 16 millimeters. 16 seems a little bit too small. I want to have it 20. So let's do that and 20. And in here, I'll add in a little 4.9. So these will not have a T-nut. There's just no use for a T-nut here. So let's extrude. Let's fix this first. Let's extrude this guy. Up to next. Add and go that way. Push it all because it's the only thing here. Let's look at this guy. Remove. Okay. All right. Let's see how that looks. Let's have a little drink. Now, do these look a little bit too plain or not? Because I am considering making a little bit of a bump here, just to like have it look more of like a bump when it's sitting on the table. Let's have a look at doing that. Let's do a new plane, offset it. 25 seems okay. And then something like this. And then it's going to be difficult to print though. I can fix that. It just doesn't. No, I personally I think this looks weird. So nah, let's move it. Stick with this kind of clean look for now. And then if I want to make it flare even more, I can just go in here, put in a higher number here. That increases everything. There we go, okay. So should we maybe start looking into putting in the bearings for the motors in the back? Get the motor mounts into position. Now, because everything needs to align here, I think I'll do it a little bit different in that I'll make a separate part studio with a sketch just for the bearing placements. That way I get everything on the right plane. So I'll do this. And I'll do this. So these are my main set of bearings. I'll need more. And I can add those doing this. Okay. So 5mm. So I'm not going to set any measurements right now, but what I'll do is I'll go in here, select the part studio, and I'll put in the actual bearing. No, that was the top one. And then I'll move that bearing from its connector there to this one right there, and flip it. Now this document will just be there for bearing locations. So let's do bearing location. So let's go back into my main assembly here, and then this guy right here. That one is put in, but this one is not. And I see that I've made a mistake. I need to move this guy to this mid connector instead. Okay. Now, if I do this correctly, looking at this from the top here, I'm going here, and I'll look at that from the top, it should be the bottom. Now, I can insert the bearing location, then put the bearing in the right spot, and that should give me a nice way to edit everything. I'll have to do 2 of these, top and bottom. Let's just rename it before I do anything wrong. So let's go into this guy, then edit in context. And you'll see that can use that one and that one. Then I can put these there. That one, is that equal to something? Let's see. Why is that stopped being able to move? Shouldn't have that type of a constraint on it. Let's do this. You go there. Let's see, select other. Just gonna delete that. Let's put this guy in there, and this guy in there. And let's put in the rest of the bearing locations. Then I need a second set of bearings back here. Alright, so that gives me then all the locations here. So for the top layer of bearings, I can just use this as a reference. Now let's put in some more bearings. I want to go in. Just makes it so that I have to do it in the assembly line. Let's see. I know what to do. I know what to do. I just need to work around something here. I need to work around the fact that I can't just put in multiples of this bearing into the document. That just means I'll have to just manually design them on each one of these. Not a big deal. I can do that quite easily. Doesn't need this one, but I'll still do it. I just move that to right first one, and then just manually make all of them. I think I'll do that actually. So I'll just open this guy and that, because here I have all the dimensions that I need. Now bearing location bottom. So that one is 15. So let's select all of these guys. Now I'm not gonna need all of these, but it's easier to just model all of them now and then not show the ones that I don't need. So now these are all 15. Then they all have this guy is 13. So which, think a little bit here, which ones do I need? Satisfying. So I do need this one. So the height there is 5. No, I don't need that one. Not able to think enough now to figure out which ones of these I do need and not need. So, need that one. I won't need this one. Yep, because it'll go from here into the motor, back around at the back, across the other motor, and then to the gantry. Okay, yeah. Then I'll also extrude this little lip. I added a chamfer on the top there, 0.5. So we'll do that again. Now I'll select all of these, make them all the same color just because that's gonna annoy me. And now if I go back to my assembly, I'll have to insert that bearing again. No, not the bearing. Bearing location. So fastened meets there. That does not seem right to me. All those parts should stay in line. Make a sub-assembly of this. Actually, no, I'll make a construction tool out of this thing right here, and that's kind of easy because I can just add in just like this, these and offsets. Just trying to figure out the easiest way to do all this. Come on, let's do this the right way. Right now, I miss IronCAD. That turns everything into one part. So if I go into my assembly, insert bearing location bottom, do a fasten mate between that guy, that guy. So now I have something to visualize where the bearings on the motor mounts go. That was a lot of work, but it'll do. So this will just be a tool. So in my finished CAD model, this won't be there because I can just turn it off. But this will be a tool for me to make sure that all my bearings are at the right spot. So when I now go to make my motor mount, this entire thing will be in the correct spot. And then the motor mount for the other side is the exact same, just higher up. Actually, it is the exact same, but with the spacers on the other side, I guess. So how far back do I want that bearing to go? That is my first thing here. Now the distance between these two. How close can I get them, I guess, is my question. So can I grab a distance from there to there? That's 50. Can I make that 48? Because the thing that I'm thinking about right now is the size of a motor. And the size of the motor is 42. And then I need the screw mounts. Let's just quickly mock up a motor to see how everything screws together. Because I've made this mistake before. And now I'm gonna need 6 millimeters for the screws. So that's 6. And then what is that dimension? I have the motor right here. There we go. Okay, so this is a motor. Why are you there we go. Just put it in a circle there. So that represents the actual size of the motor. So I can definitely make this shorter. Let's try something just drastic. What I'm looking at now is the belts. So the belts need to come from here and go from there in through this pulley, back out around here, and then straight over there. And then preferably I want access to all of these screws. So I think I need more than 35. So my issue right now is this location is good, but this one, the belt will cross straight over here, which won't work with how I want to set this up. This will work. It's a little bit too much. I can do that. Yeah, that seems reasonable. There's plenty of room here. There's enough that the belt gets a lot of contact. That's good. Okay. So far off over here. So I need to keep this guy in mind, which I can actually just do by doing. Hello, Nexus. I want to have this motor as close to there as possible. Had a thought. What if I make this distance the same as... Nope, wrong. That one the same as that one. Now I can fully mock up the location of the motor. All the bearings are in the right spot. And I'll have... How much distance do I have there? 4.5. Let's go here, just do that. Do 5. Gives me enough for a good structure. So now this is my next thing, and there's no real reason for me to just keep extending it. This just a nice round number. I don't really need this in the sketch, it just helps me put it in my head right now for where I want things to be. But now I know that I can have the motor mounted to the exact same or on these lines, and it'll be just where I want it to be. So let's go back in here, and this is how it looks now. So, mounting the motor's mounts. So I want to screw it into 3 spots: the top, the back, and the side. Alright, so let's see if we can get a motor mount going. Motor mount. Right. Now. is all based off of the frame. Just that one there. This is the rough. Just making a rough model. So that is enough for now. Put that into the assembly. Let's see. Mount to the right. Now that I have this in the assembly, what I can do is edit this in context. And then I can extrude this. Instead of going just up there, I want to go up to that. So up to face, right there. But I want to offset that by 1. So it doesn't reach all the way up, it's 1 millimeter from it. That's good. Now let's put in some important measurements here. So these are the bearings, and I'll add in these circles to visualize the bearings. Just so that I don't design anything that will interfere. Let's do that. How far up here do I want this to go? Ideally as far as possible. I'll make it 40 for now. So I have a distance here. This guy. Oops. That guy. What I'll do is I'll just move. Make these ones the same size. That sets the width of the entire thing. Now if I don't like that, I can just go in and edit the size of that one and I get a better looking thing. Now, here comes the tricky one. So I know that the motor will be on this center line. And let's just put in the size of the motor again. Actually, I don't need. I'll put in the size of the motor, but I don't need it. But it's more for a visual reference. So, you and you are the same size, and you are 42. which actually I don't need any of these. Those ones can go away. That's 31 and that's 42. So what I'm doing right now is I'm working on the location of the motor, and I'm doing tensioning on the motor like the Rook Mark 1 did. This is more in common with a Boron V0. So I'm moving the entire motor to do the thing. I can't remember. To do tensioning, I'm moving the entire motor up and down. So right now I just need to add in slots. So let's do all of these. So that one is that. So all I need to do is match up all of these. I want all the slots to move in the same amount, so they're the same size. So now I can do that one, that one, that one, and that one, and put slots on it. These are 3.5. They don't need to be 15 millimeters, I can tell you that. This guy in the middle also is a slot, but it is 22. So let's make that 23. There we go. So now I can move all of that, but I want to set this some point, the closest that I want these two to get to each other is 5 millimeter. Alright, so what is not defined now? So that distance right here, here. It's 31. I don't need any of these guys. Button. Now that sets pretty much the entire thing for the motor, but I want to add here, I need more, a little bit more meat on it. You guys are nuts. That is the base of motor mounts. So let's go to the assembly and let's put in a motor. And I'll put that in right. Nope. Right there. Now I will have to make sort of a thing here. I need to sync the motor into this part. So what I'll do is I'll make a block here that's 43 wide. I want some reference of these ones so that I can put this guy in the middle. So now, if I do this correctly, midpoints. What did I just do? Midpoints. Yeah, so now it stays there. So just need to find a size here. 2. So the distance between that, oops, distance between that and that is 5.5. So if I make this hole 6, it will be enough. Let's grab that guy. The distance between that and that is 6. So now I can slide that motor back, and that'll give me tension. I don't think that much is needed, but I'll keep it like that for now. Alright, let's do one last thing and then we'll round it up for today. So I'll edit that in context. And I'll do on this here. And that goes on to that. And I know that I don't really have a lot of wiggle room on this rail, but for in case some people have issues, I'll add in a little bit of a relief cut to this here. Distance here, let's do 15. I can easily move that later on. Let's just add in let's extrude that. Sink that down 3 meters. Now this will break. This will break the location of it, so I'll have to figure out a new way to put it on to the frame as a reference, and I'll probably just use this. So let's see how. So that hole is 67. 67. Let's change that to 60. Now this one would be wrong, of course. So I need to add a hole to this frame 60 from that edge. Let's do that quickly. Frame, top frame. Sketch here, and then I'll do a line over there. This one needs to be 60. That gets a hole. That's 5.2. I can probably move this thing to, yes, I can move it to here. Just go back and add the spot for the T-nut and all that stuff later. I'll go in here and my assembly. Now this should be broken. Yep, it's broken. So the motor mount itself can't use that reference anymore, but it can use this reference right there. And we are back to not being broken. Alright, I think that's it for today. I did get some of the work done that I wanted to get done. Because if I do this correctly, then I only have to design one motor mount and I can mirror it over to the other side. So, all right. I think that is it for me now. So I will do a stream next week, but it won't be this, it'll be building something. I'll post that on the Discord as soon as I know when it's gonna happen. But yeah, have a good one, and if you haven't subscribed, just I have to say it because you know.